Hi guys, we're Team 4 and today we'll be presenting to you our final proposed to-be process and IoT innovations for famous seafood restaurant. So what exactly are we proposing in our to-be workflow model that will help improve our overall delivery process? So here's the diagram that we came up with. So long story short, we actually introduced 4 different systems. The first being the Order Management System, OMS. Originally in our as-is process, our customers will have to call in the restaurant to order. But with the new OMS, the website now allows customers to actually order and receive updates. And this will help to reduce the overall average waiting time for the delivery process in the to-be model. Additionally, we also introduced the Inventory Management System, IMS. In our original process, we actually used paper-based forms instead for the transfer request. But with the new IMS, approval of transfers are now fully automated, and this will help to reduce the time taken for our kitchen staff to check the availability of ingredients across all the departments and the branches in the to-be model. We also actually introduced the POS, the existing POS with the new OMS. In our original as-is process, the POS system was a standalone system. But with this new integration, the orders received by the OMS will be sent directly to the POS. And this will actually help to reduce the waiting time as the service captain will not actually need to manually key in the orders received by the OMS into the POS in the to-be model. And lastly, we actually introduced a new delivery management system, DMS. In our original as-is process, we have paper-based forms and order sheets. But with this new system, the forms and sheets will be replaced with SMS notification, which will be sent to the delivery personnel. And overall, this will help to reduce the risk of erroneous inputs, especially for the paper-based forms.
I'll now be talking more about the two opportunities for IoT that we can use for our to-be process. Firstly, the restaurant can have an advanced detection of low ingredient levels. And secondly, there is now an automation of stock quantity updates in IMS. The IoT technology that we are using for both opportunities are image sensors. I'll be touching on the first opportunity, which is the advanced detection of low ingredient levels. Currently, inter-branch transfers are only triggered when the customer orders, and the OMS updates them to inform the lack of ingredients available in the current branch. Image sensors convert optical images into electric signals for displaying or storing files electronically. These sensors will automatically notify the IMS on stock levels. If IMS sees a deficit of ingredients that were accounted for in the OMS, it will recognize such decreases under the usage rate category. This means that these ingredients were used to cook the dishes and not for transferal reasons. The sensors will collect data on the rate of ingredient usage and give insights for IMS to check if it falls within the set threshold. With this improvement, the restaurant doesn't need to solely rely on the customer's order details in OMS, which was once required to trigger the IMS to retrieve stock availability. Hence, having image sensors enables IMS to be more intuitive through an advanced detection of low stock availability.
Next, our group will be covering the automation of stock quantity updates in IMS. Currently, KS has to manually update IMS the stock levels after retrieving ingredients through the IDT or IVT. Image sensors will also collect data such as the ingredient type, its location, as well as when the supplies are running low. From the data collected, the sensors will automatically inform the IMS on the stock levels across all branches or departments when it's running low. This means that the KS does not have to manually update the changes in the stock quantity every time an IDT or IBT occurs.
So now I'll be telling you about the to-be workflow model with the image sensor. So in short, every 30 minutes, the image sensor will read the usage rate of the ingredients. And if the usage rate is more than a threshold, By the way, the threshold is based on the demand of each of the ingredients or at each of the branches. If the usage is more than a threshold, the IMS will call for a transfer. If the other branches have those ingredients, it will be an inter-branch transfer. If not, the IMS will send a purchasing order to its relevant suppliers. So for the inter-branch transfers, the same process as the 2B workflow happens, just that the kitchen staff will not need to manually key in or update the IMS upon receiving the ingredients. Instead, the image sensor will detect that the stocks has been transferred, and the IMS is automatically updated. It's almost like homeostasis or like a feedback loop.
Moving on to the challenges faced for using the suggested IoT technology. So firstly, image sensors are going to be really susceptible to environmental factors like humidity and changes in temperature. Because these sensors are going to be in an environment like a kitchen, they must be customized or else it may break down or even malfunction. Secondly, you must also balance the cost and quality of the image sensors. When evaluating their performance, there are a number of factors we must consider, like dynamic range, signal to noise ratio, and low light sensitivity. So we must strike a good balance between cost and quality because that will be a challenge in itself.
Now onto the non-IoT technology. For our non-IoT technology, we chose machine learning as an application of AI, as it is one of the growing trends in the augmented analytics. Now, machine learning itself is training a model, or in other case, an algorithm, by using certain datasets to achieve an optimized model, or we can say that having a machine learn. Currently, in the 2B process, KS takes a total of 30 minutes to cook the order, including food preparation and cooking process. Using machine learning, the restaurant can predict which ingredients are often used for different periods or seasons. Now, let's say a dish called deep fried prawns is a very popular dish, and basically this machine learning model will analyze the predicted amount of shrimps needed to cook this dish, and so that we can optimize the number of shrimps, and the KS doesn't need to do any of the prepping stuff while cooking the order. And with that, we conclude our presentation. Thank you.